All right, so today we're going to work on some measuring of angles and some classical constructions. I'm kind of sad I'm not going to be here today because this is really fun. I'm hoping we get another chance to kind of work on it another day. All right, so first we're going to look at measuring an angle. So we already know that an angle can't be measured with a measuring stick, with a ruler. Because what I want to measure is the rotation that the angle makes around this vertex. So we're going to use a protractor to measure it, okay? I want you to notice three important pieces of the protractor. One, let's try to get it where you can see it. One is this T. I wanted you to notice this point right here, okay? That point right there. I also want you to notice that there's a 0 on the inside and the measurements go around to 180. And there's a 0 on the outside and the measurements go around to 180. So if I'm using the 0 on the inside, then I use the measurement on the inside. If I'm using the 0 on the outside, I use the measurement on the outside. All right, so when I want to measure an angle, we're going to measure angle 1 here. And I'm going to take the protractor and I'm going to put that little T right on the vertex. Okay, right on the vertex. Let's kind of get that in a little closer. Maybe a light will help. I don't know. Nope, not really. All right, so I'm going to get the T right on the vertex and then I'm going to rotate the protractor until the 0 is on one of the rays. So here's my T on the vertex. Here's one ray going through the 0. It's the 0 on the inside, so I'm going to follow the numbers on the inside, and the other ray goes through the 40. So that means this rotation is a 40-degree rotation. So angle 1 measures 40 degrees. Okay? All right, it's pretty simple. All right? So when you go to measure different angles, so if I put it on T, let's say I'm going to measure angle OTR. If I put the T right there on the T, if I put the T on the vertex, and then I rotate it so that this ray, this side of the angle, is on the 0, notice this time I'm using the 0 on the outside. So that means I'm going to read the numbers on the outside all the way to the other ray. So if I follow this around all the way to the other ray, angle OTR measures, and again I'm not using the inside because my 0's on the outside, it measures 164, 165. That's going to be iffy which way you go. So I'm going to say 164. If you said 165, you wouldn't be wrong. But I'm going to say 164. Okay? So now when I go to measure this angle, I have to be careful because I rounded. I chose the 164. What has to be true about this angle and this angle? This angle and this angle. They have to add up to equal 180 degrees. So if I go to measure this one and I'm trying to decide if it's 15 or 16, it's 0 on the inside, so I look at the numbers on the inside. When I'm trying to decide between the 15 and the 16, since I said 164, I'm going to say 16. If you said 165, then you should say 15 because you need these two angles to add up to 180 degrees. All right. So if the sub wants to pause the video for a little bit, you can go ahead and practice measuring the other two angles here and measuring the angles of your triangle. Okay? So she can put it on pause. And when y'all are ready, just push play again. All right. So now we're going to look at doing some work with, let's get it. Sorry, I cannot work getting everything where it belongs. Okay, we're going to work with a straight edge. A classical straight edge has no measurements on it. It's just an edge. And we're going to use a compass. A standard compass looks way more like this, but these are the ones we have, so we're going to use them. Okay, we're going to use them. Let me get one more. I want to get a different one. I think I like it better. Oh. All right, yeah, I like this one better. Okay, so in classical geometry, classical constructions, the only thing you're allowed to use is a straight edge, no numbers, just a straight edge. I know ours has numbers, we're going to ignore them, and a compass. Everything that a geometer can draw, to be accurate, they have to make it through constructions. All right? So let's look at constructing a line segment with endpoint CD, which is congruent to line segment AB. So if I had a line, I'm just going to put a little dashed line representing a line, and I wanted to draw on that line a segment that was the same length as AB using endpoints C and D. But I don't know where to put D because I want to make sure it's the same length. So for classical construction, what we need to do is we need to go ahead and use our compass, and we're going to put the center of the compass, which is this little middle of this circle, on the A, and I'm going to hold it in place. And then we're going to release this little tight thing and put the other end through this hole so I can see it, and then tighten it. Okay? All right. So this is essentially the length of AB. So when I come down here and I put this on C and I put my pen in this and make a little arc, where the arc and the line intersect is where I need to put D. So this is segment CD, and it has the same measure as AB. You're going to notice that little arc. It has a lot to do with classical constructions. We're going to move to the bottom here. I just want to show you a little example. When I want to draw a circle, I can take this little compass, make the center of the circle, put it on there, decide what I want my radius to be, and then I can just follow it around to make a nice little circle. Okay? This is the entire concept that classical construction is based on. I know that the distance from the center to the circle is equal no matter where I look. Whatever that is, it's the same all the way around. So that concept is how I'm going to do a lot of constructions. I'm going to use that idea of a circle and the equal distance, the radius, being equidistant from the center to the edge of the circle. All right. So I want to construct a perpendicular bisector. So I know perpendicular means that they have to meet at a 90-degree angle. And I know that bisector means it's going to divide it into two equal pieces. Okay? All right. So what I'm going to do, since I'm looking for two equal pieces, I'm going to use that concept of a circle to work on this problem. Okay? So I'm going to go ahead and put my endpoint at A. I want to make sure that I'm going to make a circle that's more than half the distance between A and B. It doesn't matter how big, just more than half. Then when I make an arc up and down, I'm going to leave it the same distance, and I'm going to come over here, and I'm going to make this, oops, which one did I use? I'm going to make this an arc up and down. Okay? So where the arcs intersect, this is the same distance from A and from B, because I used circles that had the same radius. And this is the same distance from A to B. So if I take my straight edge and I connect these two, I've found the midpoint of this segment. Every point on the line I just drew is equally distant from A and B. Okay? Also so happens that this line is perpendicular to AB. So I have constructed the perpendicular bisector. I made it a segment. I could have just as easily made it a line that bisected AB. Pretty cool, huh? All right. I am going to go ahead and let you explore through the rest of this. Okay? Kind of think of the concepts that we used. I guess we're going to need to bisect one together. We haven't had a bisect. So we bisected a segment, but now we need to bisect an angle. So we're going to take MJK and we're going to bisect with ray JP. Okay? The interesting thing you may not have thought about, but the ray JP, when it bisects the angle, every point on that ray is equally distant from both sides of the angle. And we're going to use that concept. So the first thing we're going to do is we're just going to measure with our compass a couple little arcs. So I know that this point is equally distant from J as this point is. Then I'm going to use that point that I just formed to make an arc and an arc. Okay, so this point is equally distant to each of those 2 points, which makes that point a point on the angle bisector. So when I take the vertex, my straight edge, and I connect it to that point, I get JP, my angle bisector. So no matter what point I pick on this line, it's equally distant from both sides of the angle. Don't you wish we had a class where we just got to do constructions all day long? All right, so I want you to go ahead and work through this on your own. I want you to really think about it. Looking here, you can see these instructions that kind of give you a hint towards how you might be able to come up with this. Okay? You can Google it when you get home and kind of play with it. All right? Basically, as far as tested material, you're going to need to be able to recognize what is being constructed. So think about how to bisect a segment, how to bisect it, and how that becomes perpendicular also. Think about how to bisect an angle, and then just have fun with it, okay? But only use your straight edge and your compass, all right? Have fun. I'll see you on Monday. There's no homework for tonight except for whatever you want to play with this when you get home. Google some of this stuff. You can Google how to do each and every one of these things, and it will show you how, all right? Have fun. See you Monday.